Imagine standing at the base of a building so tall that looking up makes you dizzy. The Burj Khalifa isn't just a skyscraper. It's a modern marvel, a structure that seems to defy the limits of engineering. At 2,717 feet tall, it's nearly 3 times the height of the Eiffel Tower and holds more world records than any other building. But here's the part that will blow your mind. Beneath this towering giant lies 330,000 cubic meters of concrete, enough to weigh as much as 100,000 elephants. Yet, despite its massive weight, the Burj Khalifa is designed to gently sway with the wind, standing firm against the harshest conditions. How does it stay so stable? And how did engineers build something that seemed impossible just a few decades ago? Stick around, because the story behind the Burj Khalifa will change the way you think about what humans can achieve. The Burj Khalifa is more than just the tallest building in the world. It's a symbol of ambition, innovation, and pushing the limits of what's possible. Opened in 2010, this architectural wonder redefined how cities around the world view skyscrapers. From its design inspired by a desert flower to its cutting-edge materials and engineering, the Burj Khalifa has set the bar impossibly high. Literally. But what goes into creating something this extraordinary? The answers are just as impressive as the building itself. We're talking about concrete strong enough to withstand extreme temperatures, a foundation that can handle the weight of an entire mountain, and an ingenious system that keeps the tower cool under the blazing Dubai sun. This isn't just a story about a building. It's a story about human ingenuity, about the limits of physics, and about what happens when we dare to dream bigger than ever before. Here's the thing. Building a structure as massive as the Burj Khalifa comes with challenges most of us can't even imagine. First, there's the weight. Think about it. 330,000 cubic meters of concrete means over 1.5 million tons of weight pressing down on the ground. That's the equivalent of 100,000 elephants standing in one spot. Without a rock-solid foundation, the building would sink, or worse, collapse. Then there's the wind. At such incredible heights, wind speeds can reach over 100 miles per hour. If the structure wasn't designed to handle it, the top floors would sway so much they'd feel like a roller coaster. On top of that, the extreme heat in Dubai, often reaching 120 degrees Fahrenheit, could cause materials to expand and weaken over time. So how did engineers overcome these challenges? Let's break it down. The Burj Khalifa's foundation is an engineering masterpiece. Its base is supported by a 12-foot-thick concrete mat, resting on 192 reinforced concrete piles that go over 164 feet into the ground. This foundation had to be strong enough to hold the entire weight of the building and remain stable even during earthquakes. The type of concrete used? A specially mixed formula designed to withstand the intense heat of Dubai without cracking. But here's the wild part. Pouring this much concrete wasn't easy. Workers had to pump it continuously for over 12 hours at a time to avoid weak spots. Imagine the pressure of knowing that even a small mistake could compromise the entire structure. The Burj Khalifa's unique shape wasn't just chosen for its beauty. It was designed to fight wind. Its spiraling, stepped design is inspired by the Hymenocallis flower, a desert plant. This shape breaks up wind currents, reducing the sway at the top, but that's not all. The building is designed to be aerodynamic, with its narrower top cutting through the air like the nose of an airplane. Engineers even tested scale models in wind tunnels to make sure it could withstand hurricane-level winds without shaking. Keeping a building this size cool in Dubai's scorching heat is no small feat. The Burj Khalifa uses a state-of-the-art cooling system that captures condensation from the air. This water is recycled and used to irrigate surrounding gardens. Over a year, this system collects enough water to fill 20 Olympic-sized swimming pools. While concrete forms the core, the Burj Khalifa also relies on 39,000 tons of steel rebar for reinforcement. If you stretched all that steel into a single line, it would stretch over a quarter of the way around the planet. This steel framework allows the building to handle both its own weight and the external forces of wind and earthquakes. Construction of the Burj Khalifa took just 6 years, a staggeringly short time for such a complex project. More than 12,000 workers from over 100 countries worked around the clock to make it happen. At its peak, the construction site was adding a new floor every 3 days. The true genius of the Burj Khalifa lies in its ability to combine beauty and functionality. It's not just a record-breaking skyscraper, it's a self-contained vertical city. Inside, you'll find luxury apartments, offices, hotels, and even the world's highest observation deck. And yet, despite its massive size, the Burj Khalifa is one of the most energy-efficient buildings of its kind. From its reflective glass panels that reduce heat absorption to its water recycling systems, every detail was carefully planned. It's a shining example of how engineering can solve even the toughest challenges. The Burj Khalifa isn't just a building, it's a statement. It proves that with enough vision and determination, humans can create something that touches the sky. From its rock-solid foundation to its graceful design, every part of this skyscraper tells a story of innovation and ambition. And here's the most amazing part. As incredible as the Burj Khalifa is, it's just the beginning. Engineers are already dreaming of skyscrapers that will make this one look small by comparison. The sky, it seems, is no longer the limit.